Welcome everyone. In this video I'm going to continue the work with joysticks. So in the previous video of this discussion I showed you some code and some work with a very crappy joystick, and that was this guy here. So this is usually advertised as the PS2 joystick, and you can change it in X and Y direction, and there is a small switch on this, so you can also use it as a button. But we discovered that the range of this is not really good. So what happens is that at this point and this point there is one potentiometer on each side, and you change the value of those resistors basically, and by changing the value you get different voltage output on these VRX and VRY pins. And that's what you measure, and by that you can evaluate the position of this. But the problem is that you start to rotate this thing and it saturates very quickly, which means that you are not using the whole mechanical range of this thing, but let's say the half of it. And I keep this joystick moving, so I move it to the very end of the range of the motion, and nothing is happening. So there is like a dead range. So there is like a dead region where the values are not changing at all, because I already maxed out the output voltage. So then I promised you that I will use another joystick, because I want to control stepper motors with this. So the third video will be the control of the stepper motors. So I got this guy here, and you can see it if I just put these things next to each other, that we are talking about something more serious now. So this is a, let's call it 3-axis joystick, but not technically 3-axis. So what we have is that we have the X and Y potentiometers, and you can see that one potentiometer is as large as the wall mechanics for this thing, so we can expect something better. So we have this movement and this movement. I can feel that this is like very rigid or very solid movement, and also the mechanical range is much larger. And you see that there are 3 wires here, and they belong to this knob. So if you see this, I can also rotate this thing here. So there is another potentiometer inside this cylinder, and that is corresponding for the, well, it depends on you, but for the rotation. So let's say you move in X, you move in Y direction, and then you rotate. And the funny thing is that I've worked and also working with electron microscopes, and they have the same controlling joystick, or very similar. So there are two panels or two joysticks, and one is moving on the X and Y direction and also rotates it. So it is using very similar thing. And there is another joystick which is used to tilt the stage or the specimen, and also change the Z of it. So this is somewhat similar. And then, since we lose the button, this guy, I just bought also a button, and this is like a very sturdy button. It has a very good feeling when you push the button down, so you can feel a very, let's say, confident resistance from the spring inside this button. So I will use this as the button. So we will have the opportunity to move around and do something with the rotation function of this, so with this, and we will use this. But this is a bit more like an introduction for the stepper motor, because that's where I will use all the functions, but in this video I will show you all the small features of this thing. So we saw that X and Y movements are available in this thing, and there is also, let's say, a rotation which is captured by these cables. So there is this rubber cover, so it protects the thing inside, if you can see it. So this is a sort of a ceiling, and then we can see that there is a metal ball there. I don't want to open this casing for obvious reasons. I don't want to destroy the mechanics inside, but you can see that it's quite similar to this thing. So it's roughly the same principle. So there is a metal cage, and the stick is moving inside that metal cage, and this kind of construction allows this very nice and free movement of the joystick. So something similar is there. So you can see this thingy, and also we can move it like this. So that's all. And also you can fine-tune the zero position of the potentiometers, because there is a screw here and there is a way for the screw as well. So actually it guides the movement of this plastic very nicely. So this is a very nice stuff. And yeah, so it seems much better as compared to the other guy here. I just tried to assemble this, but this comes without any kind of instructions. So what I have to do, I have to make sure that these pins are the pins that I think they are. So what I will do here is I will try to, yeah, so you should be able to see this. And this should be a 5 kilo ohm, and I have never measured this or something, so this is the first time I'm touching this device. So the two sides should be the positive and the negative side, and the middle should be the Viper. So if I measure the two sides, that should be 5 kilo ohm in the default position. Yeah, we accept this as 5. So, okay, now we know that this is the whatever we choose, but plus and minus. I just want to mark it so I don't mess it up at all. So then let's move it. So we know that this is 1. So if I change to the Viper, that should be half, yeah. And then if I move it, it should change. And you can see that this works with the same principle as well. So we have the two edges, or we have the two terminals. So in the middle, we have half of the resistance. And if we go in one direction, we are moving between the, let's say now there is a voltage on this, so we are moving between the input voltage and half of the input voltage, and that should be basically this direction, because the resistance disappears. So the less the resistance, the more the output voltage on the Viper. And then if we move it in the other direction, then the resistance will be 4.6, so it goes to the other direction, and therefore the output voltage will be 0, or very close to 0. So that this potentiometer works, and actually I can try it with a power supply as well. So why not try it? So I give it 3 volts only. So we tried it, and now we measure it. So let's say that this will be the negative side, and this looks solid enough. So we are on the negative side with this. This is the output voltage, and then this should be the input voltage. So now I just have to make sure that I don't short the pins, and okay. So positive input and Viper in the middle, and that goes here. and negative input, and also the negative of the potentiometer, or sorry, or of the multimeter. So let's turn on the power supply, and I gave it 3 volt, so we have the half of it. And if I move it to this direction, so then it becomes 0 volt. And if I move it towards the other direction, it increases the voltage. So let's just discuss how these potentiometers work. All potentiometers work in the same way, but here it makes more sense if I explain it. So if I measure the two outermost terminals, so let's say the plus and minus, then those should be basically the input and the output of a voltage divider. And from this circuit's perspective, this is basically just the sum of two resistors in series. So if you have a very simple voltage divider which consists of two resistors, then I will put some drawing here, but what the current sees, or the electricity sees, that it goes into the first resistor, and then there is an intersection, and that is basically the Viper, and then it can go towards the ground through another resistor. And then in total it will see these two resistors in series, and it will see the values of them, and based on the ratio of those values it will produce some kind of output voltage on the Viper. So let's see what is happening in the potentiometer when we are in the default position. And from the mechanical perspective, this is now the middle of the potentiometer. So neither it's bottom or top position, or lowest or highest setting, but it's the middle. Because now, if you would put 5 volt on the positive side, then the output would be half of it. Because now we have the voltage divider, and both the top and the bottom resistors are equal, or roughly equal, depends on how good they tuned this thing here. But let's say it's equal. So previously this was 4.8 kilo ohms roughly, so we have 2.4 now. So 2.4 on the top, 2.4 on the bottom, and if I would apply 5 volts here, then 2.5 volts would come out here. And basically I can show it to you. So, but instead of 5 volts, I just apply 3. So I have the power supply here, and I just put this guy here, and put this guy, let's say, here. So now there is no voltage, so I turn on the 3 volt power supply, and now 1.5-ish voltage should come out. And you see, it's almost 1.5 exactly. So now, let me remove this thing, and let's remove this thing, and let's go back to the ohm meter. So now I move this in this direction, and you see that the resistance went down from 2.4 to 7, and 2.4 kilo ohm to 7 ohm. So there is also 1,000 times divider between the two numbers. So now what happens is that if I go in this direction and I choose the ground here, that means that I decreased the resistance of the bottom resistor to 0. And what that means is that it will basically make the current flow through that direction, and it will skip this direction. So I should measure very low voltage in this case. So let's connect this thing again. So minus goes here, and plus goes here. So now we should measure 3 volts. or 1.5, sorry, and it should go 0 if I move to this direction. And you see it is 0. Because no voltage is going out here, because I decrease the other resistor's value, and then the current will choose that path instead of the output path. So once again, so it will be easier to go towards the ground. But this depends on how you choose the reference. If I flip it, then this direction would maximize the output voltage. So now let's go back to ohm meter mode. And now I move in this direction. So I maximize the resistance of that element, which means that the current will not want to flow there. So instead of that, it wants to flow through the voltage divider. So the output voltage, instead of 1.5, should be 3 volts. So let's test it. So input here and ground here. So power supply 3 volts, output of the potentiometer, so it's the Viper, and then the ground connections. So now we go to voltmeter mode, and we should read 1.5 here. We have that, so because we are mechanically in the middle. So I move in that direction, and that should give us the maximum voltage. So 3 volts, it's pretty much there. So basically what happens is you can see it like visually here, and then you see that input voltage, the ground, which belongs to the input voltage, and then you have the Viper. And I just put them to the two sides. So if I move towards this direction, I move towards the ground, so you can imagine it more easily like this. So I move towards the ground, so I will decrease the voltage if I move in that direction with the potentiometer, and if I move it in that direction, I move it towards the power supply, or the input voltage. So that means that, okay, it not means, but it suggests that it will increase the voltage, and that's what happens basically, that if I move in that direction, and I like visually move towards the input voltage, then the output voltage on the Viper will change and will increase towards the power supply's voltage, and at the end it will reach it. And so it can be visualized like that, and also by the voltage divider. So now we know that we can use the edges here, or the two outermost pins, but we have to be careful with this, because the input and the ground is not these two, but rather these two. So the white and the red instead of the black and the red. So that's a bit dangerous, because we always think about these two colors, the red and the black, as the plus and minus of the, for example, the power supply terminals. So this is a bit tricky, but yeah. So we discussed everything, and I showed you the demonstration of this thing. So what I will do now, I just assemble the same system that I assembled for this thingy. So some Arduino, some display, and I also will utilize this thing somehow. And we just see how this works and if it works better than this. So let's see what happens. Alright, so as you can see, everything is wired up. So this is the joystick that I was demonstrating. I put a 16:2 LCD here, an Arduino Uno, and some breadboard for connecting all the wires. But basically what I did, I just braided these wires a little bit, and I soldered them on the potentiometers, applied some heat shrink tube here and there to make it a bit more nicer. And what is basically happening is that the potentiometer positive side is, for each 3 potentiometers, is connected to the +5 volt rail of the Arduino here, and then all the ground is common for everything, of course, and each potentiometer is connected to an analog pin right here down. So A0, A1 and A2. It doesn't matter which is which, because in the software you will always be able to customize these connections. So here are the three connections connected together, but to make everything more clear for you and more easy to replicate, I will put it somewhere here. I will put a picture here and you will see all the schematics, but nothing is difficult about this connection. So as you can see here, most of the numbers are 500-ish numbers. They should be 512 if the voltage would be perfectly 5 volt, but it's not. And also I guess there is some inaccuracy in the mechanical position of the joystick as well, so we will never get the perfect data. And you see that there is a ±1 fluctuation in the values, but we have the wires here and there. There is no capacitor applied that could like smoothen the signal, but for these analog potentiometers it's usually not the way, because there will be always some small jump, at least ±1. So the best way is to just use the software and, for example, average the signal and then use the average as the real value that you want to use. Of course, with quick movement and frequent movements, it is not going to be working, but yeah, it will work if you are slow or if you are not that sudden with the movement. So let's see this thing in action. So I don't exactly know which axis is which, but I believe that this motion, because the base is slightly rotated and I don't want to move this because the wires are quite rigid. So this movement should be the X. So I just move it in that direction. And this direction increases the X. So it's not really matching the physical direction, but what I could do is that I could flip the polarity of this potentiometer, and then this direction would go towards the negative. And just to show you the demonstration, because we are here to learn, I just switched the thing. I just switched the polarity. So I just need some tweezer because there's a big mess here. So just to tell you what I did, I just removed everything from the power supply just to make sure that nothing will happen if I short the wires. But for example, if you want to move in some certain direction with a potentiometer, or you want to turn the potmeter, let's say clockwise, and it's giving you the opposite number on the wiper that you expect, then you just simply flip the outer pins. So if this was plus, this will be minus, and if this was minus, this will be plus. And then, to simply express this thing, if you move towards the ground, then of course you will decrease the voltage on the wiper. And if you want to increase the voltage with the same movement or same direction, then you just flip the things. So if you flip the wires, then you will move with this movement towards the power supply voltage, and then you will increase the output voltage on the wiper. So now let's show this in practice. So now I flip the wires here, and then this movement now should decrease the number on the X. So let's see if I was right. So 512 something. So now I move it down, and I was wrong. And I see why. So I will not cut this from the video, so the previous part, but I was just not so careful, and I was changing the wrong thing. So now let's see, this was the y-axis. So if I move it up, then it's decreasing, and if I move it down, then it's increasing. So what I have to do, I have to flip the polarity for both the x-axis and the y-axis. And what I found out now, and I was just not so careful, that the potentiometer for the x-axis is this guy here at this setup. So let's remove this thing. And yeah, this would be much nicer in real time. So if I would stream this, that would be more cool, because yeah, you would see it in a better way, because I can cut the video and I can edit the video, and yeah, therefore I could like hide these kind of mistakes. In this case I will not, but in general it's very easy. If you upload the video, you can always edit or take several takes and use the best one. But now we not doing that. So I flipped both x and y. So now if I'm correct, in this direction x should go down, and it goes down, and in this direction y should go up, and it goes up. So okay, now the polarity is fine. So first thing that we learned is we have to figure out when you put this in your box or whatever, when you make the physical position of your joystick permanent, you have to make sure that you know which direction is which, so which will be your x and y direction, which are the corresponding potmeters, and also how is the polarity. That is basically what is your reference system or coordinate system. So if you want to decrease the value of the output by moving in this direction, then you have to have a certain wiring, and if you have to increase in this direction, you just have to flip the things. So yeah, as I said, so you have the three pins or legs of the potentiometer, and then you basically measure the output between this and the ground, let's say. And if you are not satisfied with the response that you get by turning the potentiometer clockwise, so for example, let's say now this is minus, plus, sorry, this is minus, this is the Viper, this is the plus. The Viper is always the same because that's the output, but you can change between these two. So whether you choose this as plus or this as plus, that will determine your response on the Viper. So if this is the plus and you turn away from it, let's say it will decrease the voltage. And if this is the plus and turn towards to it, so you just flip the polarity, then it will increase the output voltage. So that's what we did here basically. And I haven't shown you the rotation, so that is the upper part of the joystick. So I turned it counterclockwise, at least I wired up this one well. So I turn it counterclockwise and goes towards 0, and I turn it clockwise, and then it goes up to 1023. And if you see, I start to change, and there is a huge range of motion, really. There is a small blind spot at the end, let's say, yeah, a few degrees, but most of the range is useful, not like this crap. So if you have a lot of money, you should buy these kind of things. If you actually buy this from some Chinese websites, AliExpress or eBay, you can buy this around $10 if I'm correct, or $12. I'm not sure about the price. I will put some links in the description. And this is like $1 or $2. I bought this at a local store and it was $30. So yeah, you have to pay for this. But really, if you need some precise movements and you need some precise response, unfortunately or not, you have to go and buy the more expensive stuff, because yeah, this is how we get there. And this is so solid mechanically, so I have to hold the base, of course, because there is like a very strong spring action inside this. So now you can see that, for example, I can hold the X value at a certain value because I can hold my hand at a certain place, and I can keep the resistance against the pulling force of the spring inside this constant, and then you can see that I can like hover around the same value very precisely. So I mean, with this it's not that obvious, because the mechanical structure of this, the springs and all the other connections or joints are not that smooth and not that solid. But this thing, so what I try to say with this is that yeah, this is a real quality stuff. So yeah, I encourage you to buy the more expensive stuff sometimes, because yeah, cheap pays twice. So yeah, this is just impresses me that it is exceeding my expectations. So it's very nice. So as you could see, this was a very easy wiring exercise. And we also learned that if we want to flip the directions, we don't have to worry about too much of the wires. We just flip the polarity at the edges of the terminals. And then I will just explain you the Arduino code, but when I introduce this thing to you, I already showed you the code, and I will basically use the same code. I just recycled it and changed the screen and added one more channel because of the rotation. And I removed the button, because the button now, this guy here, this is just a teaser, so I don't want to use it here. But the next video where I will use this kind of thing is that I will add a stepper motor controller to this wiring, to this circuit, and of course 2 or maybe 3 stepper motors, and we will see how we can change the stepper motors. But what my idea is to write some smart algorithm, so it will neglect the fluctuations of the voltages, and based on that algorithm we will move in positive and negative x direction, or whatever is our reference system, positive and negative y direction, and maybe positive and negative rotation, or positive and negative z direction. I don't know yet. I have to see how many motors I can find at home, or maybe I have to buy a few. But this will be nice, because you will see the Excel stepper library with multiple motors and multiple axes, and yeah, it will be a bit more complex project. So let's jump to the source code and see how this works. But yeah, it will be very easy. You will see it. So let's meet there. So let's look at the code. And as I said, this is the recycled code of the previous joystick introduction. So I will go a bit quickly, because you can check that video as well if you need more details. And also I will upload this, so see the description for the source code. And you can just copy paste the code and modify it to your own taste. So I use this liquid crystal I2C library, and here, just to make sure, I use the A4 for the SDA pin and A5 for the SCK or SCL, so for the clock pin. And these are general I2C pins, so you can just easily Google it. You don't need wiring advice for this. And then we have the pins. So we have X, Y, and R, and I was starting from A0 regarding the analog digital converter pins. So 0, 1, 2, and the comments here are explaining everything. And again, this is a recycled code, so I kept the button here. So if you add the button and you use it with the attach interrupt pin, which is the digital pin number 2, you just uncomment this part, it becomes live now, and you just use it. And we need variables for the values of the resistors, or the output voltages from the resistors inside the joystick. So X, Y, and R. And then here I have a timer for the LCD, because I don't want to update it every time. So here I kept this serial in, but I will not use it because I don't show anything through serial port, so I just comment it out. But you can always define this again or change it and use the serial. So we print something as a startup message on the LCD. So we begin, so we start up the LCD, and then in the first block, so in the upper left corner, we start with the printing, and I just write this analog joystick, and then I jump to the next line. So by changing the second argument here, you change the line. So in this, you step the rows with the first argument, and you step the columns with the first argument, and you step the rows with this second argument. So then I wait a bit, and then I go with this print LCD. And what happens there is just I print something which is permanent. So I get rid of the message from the previous printing, so this demonstration stuff. And then I move the cursor back, and I just print out the X, Y, and R, as you could see it on the demonstration. And these will stay there permanently. And then we have 3 pins, X, Y, and R, all are inputs. For analog pins, it's not necessary to define these, but just to be sure, you can. And again, this is a recycled code where I was using button. If you want to use a button, you just remove the comment signs here, and you just connect the button to the circuit. But this is how you should deal with the button. And then I start the timer by saving the time at this moment where we ask the millis function. And in the loop, we try to go quite simple. So what happens here is we read the status, or we read the values of the AD converters, those 3, X, Y, and R. And then if the time which passed since this time is larger than 200 milliseconds, then we update the LCD, we update the display, and then we have to reset the time. So the next update will be measured from the previous update, which happened here. So we preset the timer, and then we go round and round within the loop until this will be again true, and then the code enters to this part. So in the update LCD, we have those parts where we update these 3 values. And what I did is first I moved to the first part of the first line, so to the 0 point of the first line, and I delete the previous numbers by printing empty spots there. So basically these are white spaces. And then I move back to the first block again here, and then I print the value, and then I repeat this until I finish with all the 3 values. So this is what is happening there. So first, jumping to the position where I want to print, I print some empty stuff. I jump back again, because if I would continue printing here, so let's say this is not here, so the analog Y value would be after this, and not here. So the cursor would be here because we left there and not here. And by having this line here, then the code will know that it should not continue printing the analog Y, and let me just bring a Y here, but instead of that it will be here. So this is how it works, and then that's all. So that was inside here, and this is the let's call it event handler for the attach interrupt. So when this is used and we press the button and it has a falling sign, so it is originally high and it goes to ground, then we just update this value, analog button true. And based on this we would do something here, but we don't do anything here because, as I said, I'm not using buttons in this code. So basically that's all. So after updating the LCD, we update the time, And then we move back to the very beginning of the loop, because there's nothing here, nothing else to do. So read analog. So we read again, and then we see if the time was more than 200 milliseconds. And this is very quick, so it's not. So the reading will go on a few times, and after that time which is elapsed is more than 200 milliseconds, we again update the LCD. And then you can write some fancy algorithms to update the display when you have new values. But as I said, there is always a little bit of fluctuation of the values, so at the end it would be a bit difficult to write something which would neglect the jitter of the signal and would consider the, let's say, real movement of the joystick. So let's not go there, because we don't need that high precision or that good behavior. So yeah, so this was all. And as you can see, if I squeeze the code a little bit, it's under 100 lines, so it's a very simple code, and it works. But this is basically just a demonstration code, so it shows you that we can move around with the joystick, we can read the values from the joystick, and we can process it and put it on the LCD. But the next video will be more exciting, because then I will use the joystick to control stepper motors. So that would be, or that will be, more spectacular. So yes. So I hope that this video was helpful and you could learn something. Please don't forget to subscribe, because that would help me a lot. If you have some questions regarding the code or regarding this joystick or this topic in general, please leave a comment and I will answer it. And you can also visit my website. So I'm still building it, and there will be more new stuff there. But you can look around. I collected all the parts, for example, so you can easily check those parts which I am using. I have some other details there, so look around. And the website is curiousscientist.tech. And yeah, basically this was the video. So don't forget to subscribe. I hope you learned something, and see you in the next video.